In this clip, we'll take a look at how to create what's called a stem and leaf plot. And it's a really good way to organize some data that you just collected from a survey, and you've got it just kind of lying around in a random pile, and you need to make some sense of the numbers. So let's go ahead and have a look at our example survey problem. The heights of the members of two high school classes were measured in centimeters. The results were as follows. And here we've got a big long list of all the heights they recorded in the two classes. Can't make much sense of it yet. But in A, display the data using a stem and leaf plot. Then in B, how many students are at least 100 centimeters tall? So we're going to make use of the stem and leaf plot to get some information. Okay, so let's start by tackling A, where we actually set up our stem and leaf plot. In some ways, the stem and leaf plot is pretty similar to a frequency table. And if you haven't seen how to make a frequency table, check out an earlier clip for that and it'll help you out. But we're going to start out by making a little table that looks like this. We've got one column called stem and one column called leaf. Now, stem and leaf are parts of the tree, and this is named after a tree for a reason, as you'll see. What we're going to have in here is little intervals, and they're going to be the stems. And from there, our leaves will branch out from the stems this way, kind of making a weird shape of a tree system. Let me show you what I mean. To set up the stems, I'm going to make what's called intervals, or class intervals. And they're divisions in all of these numbers. So when I look at all of these numbers carefully, it looks like they're all in the 100s, and there's some in the 120s, like this one, 122. There's also some that are in the 180s, the 170s, 190s, even 130s. So I'm going to divide these up into intervals. The first one will be all of the numbers that start with a 1 and a 2, or in other words, all of the 120s. And I'll do the same for all of the 130s. All the numbers that start with a 1 and a 3 will be in this row. And we'll just keep doing that. So I'll have all of the 140s in this row, 150s in this row, and so on. So remember, that's the first step. We're going to set up the stems into little divisions that are called class intervals. Okay, now back at the top. The first stem is all of the numbers that start with a 1 and a 2. Well, let's look for numbers that start with a 1 and a 2. I go through the list and I see 122. This last number, the 2, is my leaf. Let's continue. Let's look for another 120. Down to the second row, I see another 122. So I'm going to add another leaf, which is a 2. It's the last digit in 122. Right next to it is a 120. Its last digit is 0. So that will be another leaf. Any more on this row? No more 120s for that row. Down to the second last row. Nothing there. And there's no 120s in that row. So that's all of my leaves for this stem. Let's go to the 130s. Is there any numbers that start with a 130? Well, yeah, right off the bat, the very first one has a leaf of a 6. And then I just continue. There's a 130. And I just keep doing that. So eventually I'll have all of these leaves. And there we go. There is my completed stem and leaf plot. So just to review, for all of the heights that are at least 190 centimeters, there's one student that is 190, another student is 192, and one more student who is 193 centimeters tall. And something to note, just right here, I had 6 sixes and I was going to run out of room. So on a stem and leaf plot, you can sometimes show 6 times however many you have. So for example, I had 6 sixes, so I said 6 times 6 just to make sure I had enough room in my row. For part B, it just asks, how many students are at least 100 centimeters tall? Well, now that I've got my data organized and is something I can look at, that's a lot easier to see. 180 centimeters tall. Well, that's everybody in this stem and leaf and everybody in this stem and leaf. So I just count up the numbers I have here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now there's 6 of these, so 9 and 6 is 15. 16, 17, 18, 19, 20. So the answer, there's 20 students who are at least 180 centimeters tall. And now it's your turn to try practicing making a stem and leaf plot. I'll give you an example problem that looks just like this. The number of hot dogs sold by a street vendor for each day in the month of June is recorded below. And here are all the hot dogs he sold on each day. And it's a big list of random looking numbers. But in A, display the data using a stem and leaf plot. Then in B, determine how many days fewer than 80 hot dogs were sold. Okay, so try A and B using the steps that I showed you on the left. Make sure you set up your table first and then fill in the values. I'll show you the solution when you're ready. All right, here we are. Here's our finished stem and leaf plot for this problem. This one's a little bit longer than this stem and leaf plot because we had to use more intervals. So there's hot dogs. On one day, there were 16 hot dogs sold, 24 on one day, 21 on another day, 25 on another day, all the way up to, looks like 128 was the most that was ever sold on one day. And then in B, determine how many days fewer than 80 hot dogs were sold. Looks like there's 16 days. And we found that just by counting up how many numbers we see here all the way up to the end of the 70s.